Hello, I'm Luca De Giglio, and this is the Web3 in Travel podcast, where you can learn about crypto, blockchain, and how the new internet will change travel. Today's episode is going to be pretty technical, but stay with me at least 5 minutes if you don't want to dig deeper into what I'm talking about, because at least you will learn where blockchains are going and the use cases they are going to allow in travel too in the future. So I will talk about ZK proofs, zero knowledge proofs. I prefer to call them zero knowledge protocols, because protocol always means something open anyone can use. And in short, they are a new way. It's not really new, but it's something which is growing a lot lately. A new way to do blockchains in a way, to solve the blockchain problems of speed and cost. And on the other end, decentralization. If you remember, there's something called blockchain trilemma, which is the fact that blockchains can be decentralized, scalable, and secure. Well, they can't be. In theory, you have always to give up one of these three things. So let's say if you want a really decentralized and secure blockchain, well, scalability is not there. So it has to be expensive and slow. The scalability means fast and cheap, right? So again, you want it decentralized and secure, it cannot be scalable. You want it scalable and decentralized, okay, but it won't be secure. You want it scalable and secure, yeah, great. Centralize it away and you have it, but then is it even worth it having a blockchain for that? Can we have decentralized, scalable, and secure blockchains? We really can't at the moment. There's a lot of research and experimentation. There's promising things, and we may get there in the future. And ZK proof or ZK protocols are, to the least, promising. At the simplest level, we can say that blockchains, to be decentralized, have to be expensive and slow, but a lot of work is being done to solve this problem, and it looks like we will be able to solve the problem. And if the problem is solved, then the use cases for really decentralized systems in travel grow a lot. So Web3 can solve, at that point, many more problems than it can solve today. And one more thing, so you have probably heard about layer 2s. So like, let's say in Ethereum, is a layer 1 where everything is very expensive and very slow, but very secure and fairly decentralized. Layer 2s are protocols built on top of it, where things are cheaper and faster, and basically they inherit the security from Ethereum. So they are kind of a solution to the trilemma already. Today, all the eyes are on optimistic rollups. You may have heard about Arbitrum, Optimism, and others, and they seem to be the short-term solution. So today you can actually do blockchain stuff on top of them. They are growing. Optimism is launching a token in these days. But in the longer term, there's an even better technology, it seems, which is ZK protocols, basically. So today I will talk about them in general and about ZK Stark, which is one specific project in particular. This is interesting if you want to kind of bet on a new direction before everybody else is there, which is usually what makes Web3 that interesting. We are really at the beginning. If you get onto the nascent thing before everybody else and you create a skill set, many people will need it later, or you will be able to build stuff before others. So this is for the pioneers amidst the pioneers. So really the ones who say, okay, blockchains, cool. It's too mainstream already. Give me something more niche, but which will become big, and not something like which is just going to grow in terms of, price of a token or whatever, but something which is technologically sound and interesting, like a real challenge. So you're not happy to be, or to have left the medieval Europe and to be in the new continent. You want to go farther, and you want to go even farther than those pioneers who are going to California. You want to go farther somewhere else. So that's what the ZK protocols are for. So these are the people who are going to join that. If you're one of them, keep listening. Otherwise, I think I gave you the overall idea already. Let's get technical. So from Wikipedia, zero knowledge proof. In cryptography, a zero knowledge proof or zero knowledge protocol is a method by which one party, the party who has to prove, can prove to another party, the party who has to verify, that a given statement is true, while the prover avoids conveying any additional information apart from the fact that the statement is indeed true. Wow. Okay, let me give you an example. I had to get a visa for Thailand, and the consulate asked me to go to the bank and print out my account balance. So they asked me, they wanted to make sure that I had 30 euro a night for the period I was going to stay. I was asking for a 2 months visa, 60 days, 30 euro a day, 1,800 euros. So I had to prove them, and they wouldn't accept like me showing a bunch of cash, like 2,000 euro in cash in front of them. They wanted to see the bank statement. So to prove that I had enough money to go to Thailand, I had to give them much more information than needed. I have to show them all the money I had in my bank account. And as you can understand, this is, from the privacy point of view, pretty horrible. So now everybody in the consulate knows how much money I have in the bank account. Great. Is there a better way? Well, not in banks for sure, not in consulates for sure, because they belong to another era. But do we have better ways to prove something? Well, with zero knowledge proof, I could have proved them. Like the statement would have been, yes, I have at least 1,800 euro in my bank account, but you won't see how much money I have in the bank account. So this is protecting privacy. And also, and that's the important part about blockchains, I wouldn't have to give them a lot of data, because the balance, the statement was full of data, right? While all they needed from me was, yes, I have enough. So I had just to give them basically 0 or 1. In that case, 1, yes, I have enough. Instead, I had to give them a lot of paper, right? And on the paper, it was just one paper. I had to give them a lot of data on a piece of paper. Now, blockchains have a problem with data, because when you put something on the blockchain, it stays there forever. Like a few years ago, I purchased a salad in Chiang Mai in Thailand with Bitcoin. That transaction is there and is being replicated every day by every Bitcoin node, and it will be replicated forever. One transaction for a salad. As you can understand, blockchains for this reason, they make data very expensive, because once you write something on the blockchain, it has to stay there forever, right? With zero knowledge proof, all you write is yes or no. So you understand how it makes blockchains much more efficient. So if instead of having heavy transaction containing all the information, how much Ethereum I've sent to whom, at what time, from where, etc., I just save on the blockchain a number which is 1 or 0. I'm not even sure this is 1 or 0, but like it could be a hash. It probably is a hash, but it doesn't matter. So a very little piece of information. And everybody knows that this statement is true, because the system, the zero knowledge proof system, does the calculation and does all the, proving and verifying outside of the blockchain. Then we have a much better system. And I'm reading again Wikipedia, the essence of zero knowledge proofs is that it is trivial to prove that one possesses knowledge of certain information by simply revealing it. The challenge is to prove such possession without revealing the information itself or any additional information. You know those movies where there's always somebody asking, what's happening now? you don't need to know. You are on a need to know basis. We're just going to tell you what you need to know. It's kind of like that. You need to know if I have enough money to go to Thailand. You need to know if I did that transaction. You need to know if I'm the owner of that address. I have the private keys. All I'm going to tell you is yes or no. And you know it's true because we have a system which is the zero knowledge proof. We're going to try to explain this. I'm going to try to explain this. It's not easy, but let's see a few examples. So I'm sorry, to explain how, not only what it does, but how this kind of magic is possible. And the reason I explain this to you is because I don't want you to think it's magic. I want you to kind of understand it's actually possible. Human ingenuity found a way to prove something without revealing all the information. So let me read you the Alibaba cave example. In the story, we have two parties. We have Peggy, which is the prover. So it starts with P. Peggy is the prover, the person who has to prove the statement. And Victor, the verifier. So V, the person who's verifying the statement. In this story, Peggy has uncovered the secret word used to open a magic door in a cave. The cave is shaped like a ring, with the entrance on one side and the magic door blocking the opposite side. Victor wants to know whether Peggy knows the secret word. But Peggy, being a very private person, does not want to reveal her knowledge, so she doesn't want to reveal the secret word to Victor, or to reveal the fact of her knowledge to the world in general. She only wants to prove to Victor that she knows the secret word. How do I do that? Well, that's a very hard problem to solve, but we have a solution. They label the left and right paths from the entrance A and B. Let me help you visualize this. Imagine a ring with an entrance. So you are standing in front of this ring, which is sitting on the floor. It's a very big ring. That's the cave. And it has an entrance. And being a ring, you can go left or right. So if you go left, you walk into this ring and you end up back at the entrance. If you go right, the same thing happens. It's a circle. So you walk, go around, and go back to the entrance. So again, visualize a big ring lying on the floor and you can walk into this ring. That's actually the cave. Basically, it's like another way to visualize it. You walk into the cave and the cave goes straight and turn, and you go back. So it's a circle. So as I was saying, they label the left and right paths from the entrance A and B. First, Victor waits outside the cave as Peggy goes in. Peggy takes either path A or B, so left or right. Victor is not allowed to see which path she takes. So she goes in and she chooses a path. Victor doesn't know what side she went. Then Victor enters the cave and shouts the name of the path he wants her to use to return, which is either A or B. Chosen at random. Providing she really does know the magic word, this is easy. She opens the door if necessary and returns along the desired path. So again, the door, I may not have mentioned this, or yeah, I did it, but maybe I didn't visualize it for you. The door is in the middle of the other side. So if you go in, so Peggy goes in left, she's turning, and at the middle of the road, there's a door. So to go basically out from the other entrance, she has to have the key to the door. While to go out from where she came from, not. So to have the choice to say, I'm in the cave and I can go out either side, I need to know the key. So as I was saying, Victor enters the cave and shouts the name of the path he wants her to use to return, either A or B. Choosing at random. Providing she really does know the magic word, this is easy. She opens the door if necessary and returns along the desired path. However, suppose she did not know the word. Then she would only be able to return by the named path if Victor were to give the name of the same path by which she had entered. So if she's lucky, Victor is shouting, come back the same way you came in, without knowing it, right? So since Victor, and if she's not lucky, she will not be able to do that, and Victor will know that she doesn't have the key. Since Victor would choose A or B at random, she would have a 50% chance of guessing correctly. If they were to repeat this trick many times, maybe 20 times in a row, her chance of successfully anticipating all of the Victor requests would become very, very small. So basically, she would be found if she's cheating. So if Peggy repeatedly appears at the exit Victor names, he can conclude that it is extremely probable that Peggy does, in fact, know the secret word. Now, what about the rest of the word knowing? Let's say that Victor is wearing a hidden camera. He wants this private transaction to be seen by the world. But what will people see? They will only see from the camera that Victor is shouting A and Peggy appears at A. And then the other case, Victor shouts B and Peggy appears at B. At B. A recording of this type would be trivial for any two people to fake, requiring only that Peggy and Victor agree before end the sequence of A and B's that Victor will shout. Such a recording will certainly never be convincing to anyone but the original participants. In fact, a person who was present as an observer at the original experiment would be unconvinced, since Victor and Peggy might have orchestrated the whole experiment from start to finish. Further, notice that if Victor chooses his A and B by flipping on a coin on camera, this protocol loses its zero-knowledge property. The on-camera coin flip would probably be convincing to any person watching the recording later. Thus, although this does not reveal the secret word to Victor, it does make it possible for Victor to convince the world in general that Peggy actually has the key, so she has the knowledge. You may wonder, why didn't they simply, Peggy goes in and comes out of the other side. There's a door, she opened the door, and that's it. Well, because yes, this will prove that she has the word, but a third party, it will show to everybody that she has the keys, and she doesn't want anybody else to know that she has the key, because this is happening in the open, right? And Peggy could not refute such proof by claiming she colluded with Victor, and she's therefore no longer in control, who is aware of her knowledge. There's many other examples, and if this one didn't really convince you or it was hard to visualize, go ahead and read some of them. The point is here to prove, actually, that we can prove these kind of things. From two parties can prove these things, and third parties don't know what's actually going on. Okay, because again, this is all happening online, so it's open to everybody basically. Now, this is out of the way. We have zero knowledge proofs. Now, let's go and see what's happening at the blockchain level. And let me talk to you about Starknet, which is a project I'm following right now and seems pretty promising and is also getting a certain level of adoption. Their Starknet Alpha is live on my mainnet, and it hasn't been for long. So it's a layer 2 on top of Ethereum, just to give you an idea where this stands. It's not a new blockchain, it's something on top of Ethereum. So what is Starknet from their website? Starknet is a permissionless, decentralized ZK rollup. There are others. There's ZK Syncs, which was integrated and is integrated today with Gitcoin already. So there's a lot of experimentation, as I was saying. But now, Starknet is one of them. It's a ZK rollup. It operates as an L2, layer 2, network over Ethereum, enabling any dApp to achieve unlimited scale for its computation without compromising Ethereum composability and security. Now, they are saying we have the Holy Grail. We solved the blockchain trilemma. So always be careful when you hear this, because we've been hearing this forever. Every new blockchain was better than Bitcoin. Every new blockchain was better than Ethereum, until we realized they mostly gave up on decentralization. And what is a blockchain without decentralization? It's an open database. Yeah, okay. That's not really bringing us anywhere. So this one is promising the same thing, but at least this time there's more technical reasons to believe that. In short, what it does, they allow to produce the proofs off chain, so on computers, on non-blockchain computers in a way, right? So cheaper to manage, and then verifying those proofs on chain. On Starknet, developers can easily deploy any business logic using Starknet contracts. So careful, this is different than Ethereum. You have a new language. The language is not Solidity, is Cairo. Opportunity for developers who want to be there before the others, you learn Cairo. And composability, Starknet provides Ethereum level composability, facilitating easy development and innovation. I'm reading the website, right? So something which gives me trust a little bit in them more than the classic layer one is that you cannot put too much money on it. They have a limit in ETH, which is slowly being raised. So if you want to bridge your ETH to them, you actually can't until they raise it, and you have to be faster than the others. So they know that this is very experimental. If you put money there, you can lose it because the system has bugs. So they try to limit it, and as they become more confident, they increase the limit. I think the limit is around 200 ETH today, which is basically nothing in terms of blockchains, where a new layer one after a while gets billions of dollars in it, and then they lose everything. So it's the Far West, and this is, at least here they say, this is the Far West. Don't bring too much money here. Okay, you can get killed. There's a company doing that. The Starknet rollup is done by a company which is called Starkware, and of course they're gonna have to decentralize more and more in the future. And this technology is being used in a way or other already. You may have heard about DYDX. It's an exchange. I think is like a perpetual exchange or something. Sorare, football, like fantasy football stuff. Pretty big company. Immutable. This is NFTs. Diversify and Seller. So people are using this technology already on live products, but they are kind of implemented locally for them, and it's not yet implemented as a rollup, an open rollup on Ethereum. There's no token yet, which makes it interesting because if you start experimenting on the system, you may contaminate your wallets for future airdrops. Following the same concept that when you help somebody build something and then this is built, they will give you a bit of their tokens, or other people will give you tokens. Like this happened already with Optimism, and it's a general trend. So again, don't take this as an airdrop hunting tip, but again, if you come at this stage in a technology and you help them build it and test it and use it, often crypto or Web3 basically rewards you for that. So it may be worth trying these protocols, see what happens, etc. Right now, everything you do is done on AlphaNet. There's no real money, so you can actually test out a few of those protocols for free and kind of get a feeling of what's happening over there. That's it. That's all I wanted to do today, is to show you that things are moving, scalability is coming, the frontier is expanding, and expanding in different directions, and you never know if you are jumping on the right chariot, right? If you're going with the right pioneers, are they going to end up dead in their travel west, or are they going to be the new masters of the universe? And the road is open. This is one of the nicest things about Web3, whatever you think about it. Web2 is closed. You have to go and ring at the door of a Web2 platform saying, can I join? I'm a good person. I can do this and that. They're going to let you in. You're going to do your job. There's not a lot of frontier left. Everything is being captured. Web3 is wide open, and it's the perfect place for adventurers and for, again, pioneers and people who want to learn and they want, also have fun, right? So this is one of the directions this thing is going. Where it's going to bring California or some dead end, I don't know. I just wanted to show it to you. If you are in Web3 in travel, we know that Web3 in travel is not happening tomorrow. So by the time it happens, it may happen on these kind of new technologies. Maybe Web3 in travel will happen on zero knowledge proofs. Who knows? I also want to add one thing, which I discovered in my research here. Zero knowledge proof, privacy. Oh, great. We have found a way to keep things private on the blockchain. And even the examples I gave to you were about privacy. Well, no, this is all about scalability. Unfortunately, again, no one is thinking about privacy in here. They are thinking about scalability. Why? Well, I don't know. Scalability is the biggest problem nowadays. People want cheap and fast blockchains, decentralized at the same time. People always also want privacy, but that's kind of a second thought, right? So the market is asking for scalability, and these solutions are bringing scalability. They are not bringing privacy. It's counterintuitive, but if you study this, the technology allows for privacy, but privacy requires other extra steps, which are kind of expensive in a way, or at least they require extra effort. And we're not getting them. We're not getting privacy anytime soon, unfortunately. And this is probably the biggest weakness of Web3 and crypto. But this deserves another dedicated episode or discussion. So privacy is just too big to be, considered as an afterthought here. But no, we won't get privacy by default through zero knowledge proofs, even if that sounds counterintuitive, unfortunately. So knock yourself out. With zero knowledge proofs, I'll leave a few links in the show notes, and see you next time. All right, this is the end of today's episode. I really hope you enjoyed it. For more insights on Web3, follow me on Twitter at tripluca, TRIPLUCA, and see you next time.